Okay, so right now we are going to be talking about quadrants. On your blank piece of paper, please draw what looks like an X and a Y axis. It does not have to be large. Think of this as 4 rooms or 4 separate spaces. We have 2 lines that create the 4 separate spaces. We call this quadrant 1. We call this quadrant 1, and it makes a capital C shape as I number it always. Quadrant 2, quadrant 3, and quadrant 4. And instead of using the numbers like 1, 2, 3, 4, they use Roman numerals. Now, if you forget that, you're welcome to go back into these spaces, and next to each of these Roman numerals, write 1, 2, 3, and 4. At this time, please make sure you have that unit circle out from yesterday. That will be helpful. We're going to start with the first example. In the first example, please label it example number 1. Write down 150 degrees. And make a very small, like 1 inch by 1 inch, XY axis. All right, 150 degrees. Take out that unit circle. So unit circle, you have it, right? Now if you didn't have the unit circle, I'm counting by 3s. So think of this as using the pink. I'm counting by 3s. So I'm starting at the starting line, and I'm going 3, 6, 9, 12, 15, or 150. Please draw exactly like I just did. That is representative of an interior angle that's 150 degrees. The next question you're going to be asked is, which quadrant does this lie in? And this lies in, it lands right here in quadrant number 2. The third and final question for example 2 is we want to convert. So right now we are provided with degrees. Let's write that down. And I'm going to teach you how to convert into equivalent radians. So if you did not understand that this is 1 over 6, 2 over 6, 3 over 6, 4 over 5 over 6, what would you do? Because not all of these angles are going to be common angles. Here's what we do. Remember, I've asked you to have a calculator as well. We are going to multiply by pi over 180 degrees.
How do we multiply by pi?
I'm going to show you right now. On our calculator, this would be 150 over 180 with a pi on top. So we are not going to put the pi in. That's the mistake students make. What I'd like you to do is type in 150 divided by 180. Do not include the pi symbol. And now the calculator is going to reduce it for us. Hit math, fraction, enter, enter. This is equivalent to 5 pi over 6, and we're going to circle it.
Does the pi always stay the same?
Pi always stays on top. It does, yep. We're going to go on right now to example number 2. Example number 2. Okay, in example number 2, please write down 315 degrees. 315 degrees. So the first thing we're going to do is we're going to draw our triangle. And we're going to start out with these common angles that we've all worked with. So 315, I'm thinking to myself, okay, I'm going to think of this in terms of the pink, but if you already know about the green, then go ahead and do that. So here's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, but I need to go 315, so that's going to split that. That's going to be right here. So I'm going to show that the angle starts at the starting line and goes all the way around. The second question is, what quadrant does this terminal angle lie in? That means once you make this line, where does it land? That's called the terminal angle. Once you make this line that represents this angle, where does it land? That's called the terminal angle. This lands right down here in quadrant number 4. The last part is we need to show algebraically how do we convert this. So I'm writing down 350 degrees and I'm multiplying by pi over 180 degrees. I'm going to write that down. And then once I write it down, I'm going to grab the calculator. Again, the biggest mistake I see students make, is that they want to include the pi. I'm not going to do that. 315 divided by 180, hitting math, fraction, enter, enter. And this is equivalent to not 7 over 4, it's 7 pi over 4. Example number 3, you are going to work with people around you, and then I will perform it afterwards. Here's example number 3. Example number 3, excuse me, is going to be 350 degrees. Now I know there may be some questioning. Where am I going to find that? I'm going to press pause and give you 2 minutes to see what you. So 350 is not one of those memorized angles, and that's why it's so confusing. But one time around, a full revolution is 360. So I'm going to go all the way around, and I'm going to approximate, like just before it ends, I'm going to stop. That's my terminal angle. Terminal angle is where does it stop? That's my approximation. Okay, the first question then after I draw the terminal angle is which quadrant? This is in quadrant 4. How many of you got this part right? Hands up high. Okay, now I'm going to take 350 times pi over 180, which is 350 pi over 180. Yes, I know there's maybe faster ways that you can reduce this, like slashing out the zeros, but we're going to take 350 divided by 180, hit math, fraction, enter, enter, and do not say a word, just raise your hand. Just raise your hand. Why is this not equivalent in radians to 350? Just raise your hand if you know why it's not. Okay, Andy? It's missing the pi. Now it's equivalent. So we talked about how degrees can be measured with Fahrenheit or Celsius temperature. Please listen. We talked about distance on the road can be measured in miles and kilometers. Interior angles, a terminal angle, can be measured in equivalent degrees and in radian measurements. These are equivalent. So in example number 4, again, 175 is not one of those common angles that we talked about when we talked about using the pink and the green to signify reference angles that were 30 degrees or 45. It wasn't one of those. But I know that from here, this is my start line, over to here is 180. I need to go just slightly above. So you do need to draw a line and an arrow. This is my terminal angle. Notice it's not in the middle. It's very close to beat. It's just slightly above. So this is in quadrant number 2. I'm taking 175. I multiply it times pi over 180. So I have 175 pi over 180. I'm grabbing the calculator. 175 divided by 180, hitting math, fraction, enter, enter, and I have 35 pi over 36. Looking at example 5 together. Example 5. Notice that 495 is above 360. It means I'm going to do more than one revolution. So I'm going to start by taking 495 and subtracting 360, which is one revolution. Okay, so this breaks up into 360, please write this down, plus 135. So I'm going to go one time around, that's 360, and now I need to find 135. If you need to look at your unit circle, feel free to do that if that seems to help you. But I know 135 is right here. So 135 is 3 green sectors. It's right here. So it's right here. So 3 green. There's 1, 2, 3. And this is where that terminal angle lands. That's where the terminal. Now which quadrant is that in? That's in quadrant number 2. And now I'm going to take exact same thing. I'm going to take 495 times pi over 180, grabbing that calculator, 495 divided by 180, hitting math, fraction, enter, enter, and I have 11 pi over 4. Let's look at example number 6. Okay, example number 6. Here we go. On your paper, please take 1,120 and use a calculator for example number 6 to determine how many revolutions and then where does it land. I'm going to give you a few. The first thing is where does this land? So I know this is over 360, so I'm going to start, and there's a couple different ways we could do it. One way is watch. Divide by 360, and it tells me there's going to be at least 3 revolutions plus a little left over. Does everybody see that? I'm going to go at least 3 times around. Whole number 3 plus there's left over. So I'm going to go 3 times around. 1, 2, 3. Now, what is the leftover? Okay, hold on. 3, I got to take 120, and I got to subtract 360 3 times. 3 times. And I'm left with 40. So I've gone 3 times around. I know this would be 45, so it's right about there. That's my terminal angle. 3 times around, I must see that, and where am I landing? This lands in quadrant number 1, and I'm taking 1,120 times pi over 180. So 1120 divided by 180, hitting math fraction, enter, enter, I get 56 pi divided by 9. 56 pi divided by 9. Now, if you don't have a calculator, just know that you can go into Desmos and you can do the exact same thing. So I'm going to demonstrate this right now. Give me 1 second here. So if you happen to be watching this and you're at home and you're like, how can I reduce? Please listen without talking. 1,120 divided by 180, and then we're going to hit fraction, and we can see it reduces it to 56 over 9. Don't forget to put the pi on top.